So in this video we're going to have a recap of our work on the circle using the circle formulae, and we're also going to speak a wee bit about the how we can do calculations with semicircles and also quarter circles. So we need to be confident about using all the using both the circumference and the area formulae. Need you to know the different parts of a circle, and that you will be confident when you're therefore substituting into one, that you choose the right formula, and two, that you pick the right measurement to substitute into that, and you will usually be rounding appropriately. We will be using your thinking skills to do this. You're also using your organisation skills, and this circle work has got lots of practical applications. So just a wee quick recap. Make sure you know that the radius is the distance from the centre point of a circle to the edge of the circle. Right? That's the shorter distance, the radius, whereas the diameter, right, that's the distance that goes all the way from one side of the circle through the centre point to the other. You can draw a diameter in any direction, but just make sure you're aware of which one is which. Remember, the radius is the shorter word, so it's the shorter distance. The way these two measurements compare with each other as well, a diameter is essentially like having two of these radii going across. If you think about it, there's a radius and then there's another one at the other side. So your diameter is double your radius. Another way of saying that is to say that we can work out the radius by halving the diameter. So remember that the circle formula is all to do with this pi number. This pi number has been calculated. It's basically saying that the circumference, which is the other term for the circle that you should be aware of, and remember that the circumference is just the fancy word for the curved part around the edge. It's the perimeter of your circle, and what they discovered was that the circumference is roughly just a bit bigger than 3 times the diameter. And the rough number, that when I'm saying it's a bit bigger than 3, is because it's 3.1415, whole load of other digits, goes on and on forever. It's already been calculated, but that's stored in your calculator. If you have a pi, a scientific calculator, you'll have a pi key there, and that value is already stored in there. So two formulae, one for working out that curved edge, and we do the pi number times by the length of the diameter, whereas if you've to work out the area, which remember is the space inside the circle, then the formula that we use there is pi times the radius squared. So this, remember, means pi times your r times by the r again. So it's the radius that's getting squared. That wee squared sign does not mean times by 2. It means multiplied by itself. So semicircle is basically a half a circle. So if you've only got a half a circle there, then that curved distance will be, if you were to work out c equals pi d, you would be working out a full circle. But if we only want half of it, then we divide by 2. And likewise for the area of a circle, if you've only got a semicircle there, you've got half of the full circle. So you would do the same formula as pi r squared, but then you need to remember to divide by 2. With a quarter of a circle, same idea. In terms of the measurement that you're usually given with a quarter circle, this measurement here, this actually represents the radius. If you think about what that a quarter of a circle would look like. So this distance, that's really that corner point there is your centre point, and you'd be looking to know that when you're given this distance here, it's actually been the radius they've given you. So whether or not you're being asked to work out the curved part, if it's the curved edge, then it's the full circle, c equals pi d, but then you need to just divide it by 4, because you get 4 bits like that all the way around the circle. And likewise with the area, you do pi r squared and then you would divide by 4. So still using the same formulae, it's just a matter of remembering when to half if it's a semicircle or divide by 4 if it's a quarter circle. So run through a couple of examples. Seen all this before already. Find the circumference of the circle and also rounding your answer to 2 decimal places. So the sort of processes that you should be going through. Find the circumference of a circle. So which formula will you need to use when you're doing that? So clearly, if it's the circumference, it's this one here we need to be using. And what information do you know from that circle here? So it's the distance from the centre point to the edge. So we have actually been given the radius. So we know that the radius is equal to 14 centimetres. But if we're going to use c equals pi d, that's the formula we're going to use. That formula needs the diameter. So how do we get the diameter? We've already discussed that the diameter is the longer length. It goes all the way across. We need to double that, so we get 28 centimetres. So our formula for this, you're going to have begin with the c equals pi d as your starting point, and then you're going to substitute in your numbers. So you're going to have c equals pi times 28. Now on a calculator, if you're doing this, that will usually show up as 28 pi, but you then need to press the SD button on your scientific calculator and it will bring it up as a decimal. You don't necessarily need to write that 28 pi in there, but I'm including it because it comes up in your display, and sometimes you are asked to write your answer in terms of pi, but this one is about decimals. So 87.9645, follow the other digits. So we'll be looking for you to do some rounding, right, with that, and round it to 2 decimal places. So 87.96, right, 2 decimal places means you're going to there. Because it's followed, the 6 is followed by a 4, we can just discard that, and this is a length, so you'd be looking to have your answer with centimetres. Same circle again, but this time you've been asked to find the area. So the key here, if you're asked to find the area, what formula would you need to be using? So hopefully you know it's going to be this formula, right? You pick the right formula to use. What information do you know when you look at this circle? We've already said we know the radius. So we know the radius is 14 centimetres, and the formula we're going to be using, pi r squared, that one uses the radius, so we don't need to do any other, we don't need to work out the diameter. So for this one, right, your formula, you start with area equals pi r squared. You're then going to substitute into that, so you're going to have area equals pi times 14 squared. That would come up on your calculator display as 196 pi. And if you press the SD button, then from that you will get your answer of 615.7521, whole load of other figures. And this time, remember that with area we need our units to be squared, and because we started with measurements in centimetres, our answer here would be in square centimetres for the area. Next example, right, find the area of the circle. Leave your answer in terms of pi. So this is one of these ones where we won't need to press the SD button. So what formula do you need to use? Find the area. So area, right, the formula with the A in it, so we're going to be using that formula. What information do you know? If you're looking at that circle, you can clearly see that you've been given the diameter. You know that the diameter is equal to 16 metres, but in terms of what information do you need to be, if you're going to be using the area equals pi r squared, we need the radius. So how do we get the radius? Remember, that's where we're going to half the diameter, so we get the radius equal to 8 meters. So starting with your work in here, you putting down your formula, area equals pi r squared. You're then going to substitute into that, so you're going to be writing in area equals pi times 8 squared. You can either do that on the calculator, even if you didn't have a calculator. 8 squared being 8 times 8 is 64, so your answer here will be 64 times pi, and of course we need the units, and the units here are meters, so square meters for your area is what you're looking at there, and that would be it. You wouldn't need to do any decimals or anything with that one, you just leave your answer like that. With number 3, you are finding the circumference of this circle, and it's a non-calculator question, and when you get ones like this, they usually give you the pi with the, tells you to take it as just the 3.14 sort of they've rounded the pi number so that your answer will just be slightly less accurate. But let's find the circumference. Which formula will we be using? So clearly circumference, the C formula is the one you're using, C equals pi d. What information do you know in that circle? You've got the distance from the centre to the edge, so the one that you know in that circle is you are being told the radius is 3.5 centimetres. But what information do you need? Well, the circumference formula uses the diameter, so we clearly need to be able to work out the diameter. So before we do anything else, we need to double that. 2 times 3.5 is going to give me 7 centimetres. Now I'm ready to actually do the calculation. So remember, it's the circumference formula that we start with, and then subbing in with my value of 7. So of course that would come up on the calculator as 7 pi, and you then press the SD button and you'll get your answer of 21.9911, whole of the other digits. We would round that to 2 decimal places, 21.99. And again here the measurements are in centimetres. In our next example, right, calculate, we're on to looking at a semicircle, right, calculate the curved length of the semicircle. So that is this bit here that we're trying to work out. So what formula do you need to use? Well, if it's to do with length, curved length, and clearly the one that we would be using, right, would be the C equals pi d. What information do you know? So in this diagram here, in this semicircle, that distance through the centre to the other side, you actually know the diameter. You know that the diameter is 28 centimetres, and because we're going to be using the circumference formula, which involves pi d, then we don't need to do anything about the radius. So our starting point here is you write down the formula, which of course is C equals pi d. However, this is a semicircle, so what we need to remember about with a semicircle is that our circumference is going to be halved, right? We've only got half of the edge, we don't have a full circle, right? So because it's a semicircle, right, remember that you will need to halve your number. And you can do this all at once in the calculator. So substituting in your values, you're going to have pi times 28 divided by 2. On your calculator, that would show up as 14 pi. You then do your SD button, and that would come out to be 43.9822, all of the other digits. And rounding that to 2 decimal places would be 43.98. And again, right, we're on centimetres would be for your answer there. For part B, it's the same semicircle, but this time you're trying to get the area, which is the space inside it. So calculate the area. That means that what formula are you going to be using? You're going to be using the area formula, so A equals pi r squared. In terms of what information do you know in that circle? Well, you know that you've got the diameter, you know the diameter is 28 centimetres. However, what information do you need to use the area formula? You need the radius. So you're going to have to, first of all, half that diameter to get the radius to be 14 centimetres. Once you've done that, you're then ready to start the question, and you're doing area equals pi r squared. Of course, because it's a semicircle, we need to remember to half this calculation. So we're going to do area equals pi times 14 squared divided by 2. If you do all of that on the calculator, it will come up with 98 pi. And of course, SD button will produce the answer of 307.8760, and you'd get your final answer 307.88 when you round that. And again here it's area units, so make sure you've got square centimetres when it is area. Final example we're going to look at, calculate the area of the quarter circle. So key thing, area is mentioned. So which formula do you need to use? So it's clearly going to be the area formula we are using. What information do you know? So on this diagram here, we've just got a quarter circle, but remember, a quarter circle, this little bit here, these 3.2 measurements that you can see, they're actually, what information do you know? Well, that's telling you the radius of what would be a full circle if you were to draw a full circle around that. So you actually know that the radius is 3.2 meters. So what information do you need when you're using the area formula? It is the radius that you need. So we don't need to do anything about the diameter there. So we begin by writing down your formula for the area, and then you're going to substitute into that formula. So you're going to have area equals pi times 3.2 squared. At this point, that would give me a full circle. However, remember, I'm going to write this in up here, that actually because we've got the quarter circle, what we need to remember is divide by 4. So I'm going to put that in there as well, and on each line. So write it on each line because you're working for a quarter of a circle. If you do that on the calculator, all of that together, it will bring you up the answer of 8.0424, whole load of other digits. We can round that to 2 decimal places, 8.04, and square meters for your area. So try to use this sort of, what formula do you need to use? What information do you know from the diagram? What information do you need to be using the formula? Try to use that to think through before you just launch into doing a calculation. And I would maybe suggest copy and go back through the video. You could pause and copy down some diagrams if you think it will help you with your notes.